The tiger is one of the most feared of all the big cats. A native of Asia, he has the reputation of being a man-killer. But if he's free to do as he pleases and has an open escape path, he will usually avoid people. Unfortunately, if he feels threatened or is being mistreated, he can suddenly turn into a vicious killer. When working with a tiger, treat him with great respect. Be sure to leave him an easy escape route, and whatever you do, don't tease the tiger. In this film, we're going to meet a different kind of tiger, an invisible one. One that's around us in many different places every day of our lives. Unfortunately, people often tease this tiger without knowing it or without realizing what this tiger might suddenly do to them. This invisible tiger is pressure, air pressure. And we're going to show you what it does in this modern world when well treated and what it can do when it's teased or mistreated. People have used air pressure for thousands of years to turn windmills, move sailboats. Today, air pressure lifts airplanes skyward and keeps them there. It operates tools and machinery, and when it's used in braking systems, it'll stop heavy trucks and trains. Before we go further, let's take a look at the word pressure and make sure we know exactly what it means. An engineer will tell you that pressure equals force divided by area. Think of force as being push. Then the equation becomes this. Pressure is push per unit of area, or for maybe another simpler way to look at it, this book is pushing on the table. Actually, it's only pushing on part of the table, the part it's touching. An area 8 inches wide and about 10 inches long, giving an area of about 80 square inches. To find the pressure created by the book, we can assume the book weighs 8 pounds, and then apply the engineer's equation. Answer? About 1/10 of 1 pound per square inch. The wood can easily stand that low pressure, and the book causes no damage. Now, suppose we take this nail and put the book on top of it. In that case, the weight of the book is pushing on a much smaller area, just the point of the nail. Now the pressure acting on the table just under the nail will be thousands of pounds per square inch, depending on how sharp the point of the nail really is. That's more pressure than the wood can support, and the nail makes a small hole. A small push on a very small area becomes a high pressure. Now, it's also possible to get a very big push from small pressure. All we have to do is to push on more area. A moderately strong breeze will push on this sail with a pressure of only about 1/10 of a pound per square inch. Since the total area of both sails of this little boat is about 62 square inches, such a wind would generate a push of about 6 pounds. Now, that would be enough to move this model boat very fast, but obviously it wouldn't move a real one. But if we make this sail much larger, say 20 feet high and 10 feet across, the area would be over 14,000 square inches, and the same wind becomes a push of over 1,400 pounds. Now, that's more than enough to move a 2-passenger sailboat. The important point is that a small pressure acting on a large area can become a very big push, and that big push is a tiger. Meet Al King, Executive Deputy Director of the United States Parachute Association. Al is also an instructor in skydiving, one of the fastest growing sports in the world. When he and his students skydive at 15,000 feet, they know that air pressure under their chutes will allow them to land safely and gently on the ground. Just how much pressure are we talking about? Less than 1/10 of a pound per square inch. That's right, less than 1/10 of 1 psi. But it's pushing on a lot of square inches. Here's another example. Air pressure on the bottom of the wings of this 747 is just slightly greater than air pressure on the top of the wings. In fact, the difference is less than 1 pound per square inch. A very small pressure acting on a large area can make a big push. In the oil business, people work with high pressure every day. Here's what happens if water plus nitrogen gas under 8,000 psi is not treated with respect. It's a big tiger. Now let's see that again in slow motion. Now that was high pressure acting on a small area. If we go back to the engineer's equation, we find that the total force pulling the weakened connection of this treating line apart was about 25,000 pounds. That's a lot of push, and it can do a lot of damage. What about low pressure on a large area? This is the air pressure tiger in its most dangerous form. Why is it so dangerous? Because people do not treat it with respect. They find it hard to believe that 5 psi can be more dangerous than 10,000 psi. That lack of understanding and respect results in teasing the tiger. Meet the main characters in our film. 4 large steel bottles. Together, they make up what is called a bulk trailer. This one is used for handling dry cement in the oil fields of Algeria, but similar systems are used all over the world for many other purposes. When air is forced inside big containers like these, it becomes a fierce tiger. Every square inch is being pushed hard, and there are a lot of square inches. The bulk carriers will be deliberately overpressured to show what the tiger air pressure can really do. There's a lot of preparation needed to record this event on film. Here's the camera crew getting ready for some preliminary shots. Now, naturally, not everyone understood why a bulk trailer was to be deliberately destroyed.
Hey, Eric, what are you doing up there?
Well, you see, I'm going to show you. Do you know what those marks are there?
No.
Those are... Hand me that hammer. Those are hammer marks. You see, all those marks were made by hammer blows, and all the marks on these tanks were made by people who don't realize how dangerous it is to work with pressurized tanks, even if it's low pressure. Obviously, these tanks are not pressurized now, but what we want to do is to explode them to really show the potential danger of working with large volumes of air under pressure.
So because of these marks, you're making this demonstration?
Yes. We have chosen the old tanks, which do not meet our safety standards any longer, because of the weldings which are not correctly placed, the main supports are not right, and they don't have pressure relief valves at the top. Therefore, we had junked them several months ago, and now we are going to deliberately cause them to explode.
Do you know exactly what's going to happen?
No, but we'll soon find out.
Thousands of people have hit thousands of pressurized cement silos hundreds of thousands of times, and nothing has happened. Take a look at the bulk silos in most of the oil fields of the world. What they don't realize is that if conditions are just right, hammering on a silo will cause an imperfection in the steel already under stress. Hammering is like scratching or scoring a piece of glass. Makes it easy to break. If you hammer on the weakened spot or imperfection in steel under stress, then you're really teasing the tiger. People who hammer on pressurized tanks have lost respect for air pressure. They're extremely careless, and they are teasing the tiger. Now, once they start treating the tiger casually, they risk everything. Here's what happens. Sometimes hatch covers or valves or connections start leaking under pressure. It causes problems and delays to stop the entire operation and repair leaks. So people who don't respect the power of the Tiger may do something very dangerous, hit something under pressure. For example, there is, of course, no pressure in the tank. Once in Argentina, a man noticed air was leaking from just such a hatch cover. He climbed to the top of the pressurized silo to tighten the wing nuts. As he hit the first blow, a bolt broke. The increased stress then broke the remaining bolts. The silo was under about 35 psi air pressure, meaning the total push on the hatch cover was about 24,500 pounds, since the hatch cover had an area of about 700 square inches. Unfortunately, that hatch cover flew open and hit the man in the head with a force of over 10 tons. We don't like to think about it, but the man died a terrible death. Other accidents have occurred when people did not give the Tiger the respect he deserves. There weren't any cameras on site to record an accident in Nigeria, so we'll try to recreate it for you. He had decided to open a hatch cover on a pressure silo. He thought the pressure had been bled off, but a line was plugged and there was still some pressure in the silo. Not much, only a few psi, but still a small amount of pressure. When he loosened the last hatch on the cover, in this demonstration, air pressure inside the silo was 4 psi, only 4 pounds per square inch. Take another look in slow motion. Look what those 4 pounds per square inch did to this mannequin. In the accident in Nigeria, the man was not killed. He did suffer numerous broken bones and internal injuries, and he spent agonizing weeks recovering after an emergency evacuation flight to Europe, but he did live. Others have not been so lucky. An accident in the Middle East involved a silo with an estimated 3 psi trapped inside. When the hatch cover struck a man a glancing blow on the head, he suffered permanent brain damage. Somehow, the Tiger, air pressure, had not been treated with respect. Just what should you do to avoid teasing the invisible Tiger? Let's ask Al King, the skydiving instructor, what he and his students do.
Maintaining the canopy in proper condition and working order is obviously absolutely necessary. If we don't, we end up exposing ourselves to unnecessary risk and possible death.
Before each jump, they also check their altimeters, the small gauge they carry on their chests. This instrument tells them how high they are above ground level, or to put it another way, how close they are to the ground that they're approaching at over 120 miles an hour.
In order to ensure that our altimeters are reading accurately, we will compare it with the other altimeters the other skydivers are wearing, or of course, the aircraft altimeter. Of course, if we feel that there is any problem with our altimeter, we will send it to the manufacturer, who can clean it, change parts if necessary, and check its accuracy in a barometric wind tunnel.
Al King is a professional, as are the astronauts who pilot the space shuttle. All of them depend on simple air pressure to land safely. Like all professionals, they always keep their equipment in perfect order, make sure they understand the dangers of what they're doing, and never forget to attend to important details. True professionals in the oil field should do the same. Always keep pressurized equipment in perfect condition, use gauges and instruments to measure what's happening, and never tease the Tiger by losing respect for air pressure. three largest silos were to be pressurized one at a time while everyone watched expectantly. However, they were old tanks and the seals were not in good condition. Leaks developed, and it wasn't possible to build pressure high enough to explode any one of the three large silos. Either they could weaken a silo so it would blow at a lower pressure, or repair all of the leaks and build the pressure even higher. After a few moments, they decided to weaken one tank and strengthen another by welding all the hatch covers shut. Once again, pressure began to build. This time in a weakened silo with new seals under the hatch. Any second now, the pressure is about 20 psi. The noise from leaking air pressure was so loud, it seemed certain the pressure would not go higher. Our cameras were turned off and away from the silos when metal failure finally occurred. The weakened silo flew into the air a good 30 feet, time enough for the cameras to be turned back on and catch it on the way down. Here's a good indication of the true power of the Tiger. At the instant the silo failed at the weakened points, force or push on the top was about 300,000 pounds. The first explosion was impressive, but it was a weakened silo from which the Tiger escaped. The next step, to build pressure in a silo strengthened and sealed to withstand far more pressure. A mannequin was placed near the hatch cover in order to see how much punishment a person would take as the Tiger breaks free. Then it started. This time, pressure built rapidly. And suddenly, the silo began to expand, to swell, to stretch. Before pumping started, the separation between the two large tanks was several inches. Now the narrow gap had closed until the two silos were almost touching. Proof that the Tiger was exerting his tremendous strength to break free. And then, when the dust from the small amount of cement that was inside the tank had cleared, the scene was impressive. For the skeptics, this was a convincing illustration of the power of low pressure acting on a large area. This large piece of metal, the dished end top of the tank, was blown 70 meters. The frame of this bulk trailer was bent and twisted. At the instant the Tiger escaped, engineers estimated it was exerting a total force of nearly 2 million pounds, fighting to pull the top away from the bottom. Now, let's take another look at the powerful force of the Tiger. The powerful force of large volume, low pressure, 2 million pounds of force, an example none of us should forget. When working with pressure, remember, even when it's as low as 5 to 10 psi, it can cripple and kill. If you treat this force, this Tiger, with respect and caution, Never just assuming pressure has been bled off or that the regulators and relief valves have been maintained. Remembering the power of low pressure, high volume, you will never be in danger from a tiger. An animal trainer once told me that a tiger can be trained but never tamed. Well, that same bit of wisdom applies to our tiger as well. We have him trained to work for us as long as we treat him with respect. Respect for low pressure as well as high. But above all else, when working with any pressure vessel, please don't tease the tiger.